Hello and welcome. Introduction. So let's begin by exploring what is a monitor program. A monitor program is a system software that allows a user to interact with the hardware, typically through a serial terminal. And now it allows software developers to inspect, modify, and execute code. Now, some key functions of a monitor program are memory inspection and modification. What that means here is that this function here allows user to view and modify RAM or ROM contents. Then the next key function would be register display and modification. This is very similar to the first one, the memory inspection, where it provides access to internal CPU. And then the third common key function is program execution control. This includes commands to jump to a specific address to execute a program. For example, a G command for go. That's a common what they call feature of common function. Then there are functions where it provides breakpoint handling. Some advanced monitors allow setting breakpoints to pause execution for debugging purposes. And another common key function is serial communication, where the user interact with the monitor program via a UART interface. EdMon52 or EdMon52. Introducing EdMon52. Now, EdMon52 stands for Educational Monitor AT89S52. So this is a monitor program written for the AT89S52 microcontroller. Now the AT8952 is a AT51 variant. And this monitor program, I've written it with the Keil MicroVision IDE. So here are the following are the EdMon52 key functions. So the first function it can do is a memory inspection, modify external memory, register display, program execution, and serial communication. And here is the EdMon52 screen capture taken from the Keil MicroVision IDE software. By the way, EdMon52 is a work in progress. Overview of EdMon52. Flow chart. Okay, so here is an overview of the EdMon52 flow chart. So we start off with initializing the serial communication. Then we display the command menu, which I've shown earlier. Then it gets the user to type in the command. The command being typed in or input by the user get passed to the select command routine or subroutine. Then, depending on the command that is selected, it will then execute one of these subroutine. So if a user type in C, then it will execute the change command. If the user type in a G, then the execute command would subroutine will be executed. If an M is selected, then it will display the memory. If an R is selected, then it will display the registers. And then if a Q is selected, then the quit command is executed. So, and then when any of these subroutine is executed, when it's finished, it will then go back to get another command. All right, so this is like an endless loop. The program. Complete listing. Okay, so what I'd like to do here is to give you a quick overview of the EdMon52 software. Now, before I go any further, I'd like to acknowledge that the EdMon52 is inspired by a software called MINMON. That is the Minimal AT51 program by Stephen B. Lee. Now, I'd like to acknowledge that the some of the subroutines used is adapted from the MINMON program. Now, these subroutines that I have used or adapted from MINMON is marked by an asterisk. So whenever you see an asterisk next to a subroutine, that is taken from the Minimal AT51 monitor program by Stephen Lee. Stephen is a professor from Massachusetts Institute of Technology, MIT. You can get hold of the original MINMON program using this link. I have provided this link in the description. Now, at the time of making this video, or rather at the date of making this video, that is April 2025, this link is still active. Okay, so let's start off with this part here, the stack. Basically, I've equated with an address 2FH, and then the error flag, I set the value to 0. And then I state the origin of the program and an L jump to start, which is the main program. Yeah, here is the main program. I will talk more about this later on. And then this is followed by the monitor jump table. And here is the start of the monitor commands routine or subroutines. The first one is the C command. Basically, this allows the user to modify the external memory location. And then we come to the G command. Basically, this executes the program store at the 4 hex digit address entered by the user. So, for example, if the user type G and then followed by a 4 hex digit, the subroutine will go to that address and execute the program. And notice there's an asterisk. This I have adapted it from the MINMON program. Next follows the M command. This is the longest routine here. Basically, this will display the hex and ASCII values of the memory locations. Okay, so it's quite long. All right. And then the next command is the R command. Basically, this will display the contents of the registers. And then the last command is the Q command or the quit command. This will return the control back to the main program. And then follows This follows by a series of shorter subroutines, or I call them support subroutines. This will display the command menu. Sorry, I've gone too fast. This will check the data point low register, and this will initialize the serial port of the AT51. This will display the next address, and this will display the error message bad command. And this one here will display the error message for bad parameter. And here is the get command. This will get the user to choose what command he or she wants to use. And then this is the command selector. And this is a subroutine that sends the character to the serial terminal. This will get a character from the user. This will get a byte subroutine. And this subroutine here is to generate a carriage return, a line feed. This is a print hex subroutine. And this is the binary to ASCII conversion subroutine. And this is the ASCII to binary conversion subroutine. Here is the print string subroutine. And this subroutine here will handle the control characters. Here, this subroutine will add a colon and a space. And this will generate a new line. And finally, here is the test program that I mentioned earlier. And that's it for the complete listing. Main program. Okay, so what I'm trying to do here is to examine this main program, all right? And then try to relate it to the flow chart that we looked at earlier. So let's now, okay, before I go any further, I'm going to assume that you have a working knowledge of the AT51 assembly language. All right, so let's start off with this two. Here, I'm declaring two constants. All right, one is stack. I've equated that to 2FH. All right, so it has this value assigned to this constant stack. And then error flag, I've assigned it a 0. Now, the error flag is used to track errors. All right, that's the purpose of the error flag. Then I have the ORG here at 1000. So what this means is the whole entire program starts at 1000 hexa, and L jump here will jump to this part here to start the program. Now the first instruction here is to assign stack, which was assigned to FH earlier, to the stack pointer. SP is a stack pointer, so this gets copied into the stack pointer. Here we clear the EA bit. All right, EA is the enable all bit in the IE or interrupt enable register. So the EA bit is a bit in the interrupt enable register. And then here we call or initialize the UART serial port, which is represented by this box here in the flowchart. So the start here refers to all this. Then we call the command menu, display the commands available. So we call this routine here to display the menu. Then we clear the EA bit again to get it ready to get the command from the user. Then we clear the error flag, which is this one here. Then we print this, we call this routine called print string to display the prompt. Now, OD hexa here represent the carriage return, and OA hexa here is the line feed, and this will get executed by the print string. And then finally 0H here is the null terminator. Then we come to this clear RI, that is to clear the receive interrupt. Then we call the get command, and then we save the command in to register R2. The command could be one of these, either C, G, M, R, or Q. So whatever that is inputted by the user gets saved, stored in the accumulator or A register, and then stored in R2. All right, to preserve the command, and then jump to the command selector. The command selector will then select one of these commands. Now that depends on what is being typed or inputted by the user. Let's assume the user chose the C command. It will then execute this routine. All right, execute the routine, and then when it's done, it returns to this part here, which is this part. It returns here, and then to get another command. So this becomes a endless loop. Monitor command routines. C command. This command enables the user to change the contents of the external memory. So this is the C command, or the change command. All right, so it starts off with sending the space character. So that's taken care by these two lines of code here. And then it gets the high byte address, preserve the address, the high byte address, and then display that address. So that this is taken care by these few lines of code here. Let me just scroll up a little bit. Then it gets the low byte address, preserve the low byte address, and then display that low byte address. So that's taken care by these 4 lines of code here. And then it generates a carriage return and line feed. So that's taken care by this line of code here. And then it displays the complete address. That's taken care by this 5 lines of code here. And then it sends the space character again. That's here in this flowchart. Then it gets a byte, data byte. Now this byte here is the actual data stored at the address pointed to by these blocked here. All right, whatever that address that is displayed, this one here is the data that is stored at that address. So it's stored at the data at the new address, display the stored data. All right, so that's taken care by this. And then it increments the address. It points to the next byte of the address of the next byte. All right, which is taken care by this INC instruction here. All right, then it generates a new line, which is here. Then it displays the new address, because this is pointing to the new address. So we display the address, gets the data stored at that address, and then store that new data at the new address, display the data. So it's all taken care of by this instruction here. So this here will print the address, print the space, get the data, store it at that address pointed to by the high byte and low byte of the data pointer. All right. Store that at that pointed to by dptr, then prints the data, and then comes here. This here is this part here. All right. So if the data that is stored, that is received or gotten, if the data is 0, it will then go back, increment the address. Okay, J and Z get another input, goes back here to get the next address of the next data. All right. If the byte, the data stored at that address is 0, it ends the command. All right, it ends the loop. Okay, so I'm running the EdMon52 version 5 in the Keil MicroVision IDE. So the program has displayed the command menu, all right, which is here. So the command that I want to try out here is the C command, which we discussed a few moments ago. So I go down here, I type in C, all right. Now, I should now type in a 4-digit hex address. Now, I want to change the memory location 0000 hexa in the external memory. So before I punch it in or type it in, let me examine the external memory. At the moment, everything is 000, as you can see. All right, so let me go back to the serial terminal. All right, then I'll type in the high byte address first. So 00, followed by the low byte, which is also 00. And then it displays the complete address, having typed in the address. Now, let's assume that I want to type in 44. I want to store 44 hexa in this location. So I type in 44. It moves on to the next location. Now I want to type in AA hexa. All right. And then let's say I will do 55. All right. And then let's say I want to terminate now. I need to type in 00. All right, so it terminates. Now, how do we know that we have actually entered this successfully into those locations? So let's go to the memory window. Here, I've got the external. X is for external memory. And you can see 44, AA, and 55. So we have successfully input the data into these locations in the external memory. G command. This command allows the program to jump to a specific memory address and execute the program stored at that address. Hey, so this is the G command or the go command. So it starts off with moving the space character into the accumulator or the A register, and then display that space character. So that's taken care of by these two instructions here. Then it gets the high byte address, save the high byte address in R7, and then display the high byte address. So that's taken care by these three instructions here. Let me just scroll down, or scroll up, sorry. And then get the low byte address, push the low byte address, or push the LSB byte, the least significant byte of the jump address onto the stack, and then display the address. So that's taken care by this these instructions here, and then it generates a carriage return and line feed that is taken care by this instruction here. All right, and then we call the high byte address from R7, and then push the most significant byte of the address onto the stack. All right, that's taken care by these instructions here, and then it returns the to the main program, which is taken care by this instruction here. So that's the G command. Okay, so at this point of the video, I'd like to demonstrate the G command. Now, to demonstrate the G command, I need to draw your attention to a test program which I have included in the EdMon52 program. This is at the end, towards the end of the program. I've shown it here. All right, so I'd like to show you in respect to the whole program. Let me just scroll back up. So this is the EdMon52 program, and I have included the test program towards the end. And the test program starts at an address 4000 hexa. So it starts at that address, and the purpose of the program is to display this message, test program. All right. So later on, when I demonstrate the G command, I'll be using this address. Okay, so I'd like to demonstrate the G command. So for the G command, I need to type in G for go, and then followed by the address of the program that I want to execute. Now, as mentioned earlier, my test program is stored at address 4000 hexa. So let me just enter that address 4000, and it has successfully executed the test program. M command. This command displays the hex and ASCII values of the specified memory locations. Okay, so we are now looking at the M command. So it starts off with printing the message, which is this one here, and the message is address. Then it gets the high byte address, and then preserve the high byte address and then display it. So that's taken care by these 4 instructions here. So next is to get the low byte address, preserve it, and then display it. So that's taken care by these 4 instructions here. Let's just scroll up a little bit. Then they restore the high and low byte address, and then display the colon, which is taken care by these instructions here. Let me just expand this a little bit. Then it goes to the display one row part of the code. So it starts off with initialize the counter, which is R3, which is this one here, and then save the dptr, the data pointer, which is this part here. Then it goes to this part back, which is this here, clears the accumulator, fetch the hex value from memory, which is using the dptr register, and then convert the contents. Now this square bracket with the ACC means the contents of the accumulator or the A register, the contents of, all right? So it will convert the contents in a accumulator or A register to ASCII and then display that. So that's done, carried out by these instructions. Let me just scroll up a bit. And then it increments the dptr to point to the next data. And then it decrements the counter register R3, asks the question, is the contents of R3 0? If no, it goes back to the display one row part, which is up here. All right. Now, if the contents of R3 is 0, it displays the value, reset the counter R3. So that's been done here. All right. And then let me just move this here. And then it goes here to, again, this will handle the control characters. Now, control characters will not be displayed properly, so the control character routine will print a full stop, a dot. All right, and then that's been handled by this part here. Then they increment the pointer, point to the next data, and then decrement counter R3, ask the question, is the content 0? If no, then you go back to again, so we repeats that. All right, it goes back here, repeats that. If it's yes, that is. If it's yes, it will restore, or rather, it will preserve the high byte and low byte of the data pointer, then print a new line, generate a new line. All right, so that's taken care by these instructions here. Then it decrement the row counter, which is address 42, decrement the contents of that, which is the row counter. Is it 0? If it's yes, then it ends here. All right, let's go to this end here, which is this part here. Wait for a character. If the carriage return is not pressed, it goes back. So it keeps looping until something is pressed, and then it will return back to the monitor at the beginning part. Now, if it's no, it will increment R4, and then it asks a question, is it equal to 10, which is that's decimal, sorry, that should have been. So that's 0, A in hex. So yes, goes back to the to this part here. If it's no, all right, if it's no, it will go back all the way back to display one row, which is up here. All right, so that's basically the M command. So, okay, so let's take a look at the M command. All right, so I type M, and it's asking for an address. I will look at the content starting at 1, 0, 0, 0. Now this if you recall, this is the start address of the EdMon52 program. All right, and the M command now display 10 rows of hex values. These are the hex values, and these are the ASCII characters. So if you see a dot, all right, that's a control character. All right, so the M command display the address, follow the row of hex values, and followed by the equivalent ASCII values. R command. This command displays the contents of the registers. Okay, so here we are looking at the R command or the register command. Basically, this routine displays the contents of the registers. So it starts off with printing a new line, which is taken care by this 2 lines of code. So basically, it will call the print string subroutine, and then this ODH, that's the OD hexa, that's the carriage return. OAH or OA hexa, that's the line feed, and 0 is the null terminator. Then next it selects register bank 2, which is here. Now I could select 1, 3, but for this demonstration, I'm already selected bank 2. In the future, we could add a feature to for the user to select the bank registers. All right. So, but for now, in this example, I'm using bank 2. All right. And then here is to initialize register R0, which is this one here. Then initialize counter R3, 08 hexa. Then you come to the return, this part here. So the first thing when you come to this part is to clear the accumulator, which is this one here, and then get the register value into the accumulator, which is this instruction here. So whatever is stored in that particular register, that is copied into register A. And then it saves the contents of the register. This square bracket ACC means contents of the accumulator or A register. All right, save the contents of the A register or the accumulator onto the stack. All right, that's taken care by this. Then next two instruction basically converts the contents of the accumulator to ASCII, display the first hex digit, then get the second hex digit and display it. So that's taken care by these two here. Sorry, here. All right, taken care by this to this one here. And then it pops the retrieve the contents of the accumulator, then display the space character, that's taken care by this one here. Then increment R0, which is this one, that basically point to the next register. Then increment R0, oh, that's done. And then we decrement and ask the question, is the content 0? If it's no, go back. All right, if it's the content is not 0, go back here, and then carry these instructions out. Now, if the contents is 0, if the contents of R3 is 0, then you jump back to the, it then ends the loop and gets back to the beginning of the main program. Okay, so let's take a look at the R command. Now, this is fairly simple. You just press R, and it will display the contents of the register. This is register R0 all the way to register R7. Now this bank 2 registers. Keil command. This command will return the program to the command menu or the main program. So this is the Q command or the quit command. It's the simplest and shortest of the command routine. So basically it generates a new line, which is this one here, this line of code here, and then it jumps back to the start. It returns to the start. Okay, so I want to demonstrate the Q command or the quit command. So to do this, let me just execute the G command. Now I can choose any other command, but I'll choose G for Go. So G, I want to execute the test program, which is at 4000 hexa 4000. Okay. Now, if I want to, now let's see what happens when I press Q. Okay, so when I press Q, it returns, the program returns to the command menu. So that's the effect of the Q command. Monitor support subroutines. Hey, so for the monitor support subroutines, I won't be going into or I won't be explaining too much about it because I think they are fairly straightforward, and the comments in the documentation provided, I think, is sufficient to understand them. So I will leave it as it is, and I will continue to improve the comments and the documentation and post it in the GitHub. Now, I will provide the link to the GitHub in the description. Okay, so for now, I'll leave the support subroutines as it is. Okay, so that's it for this video. I hope you found the contents useful. I have posted the flowcharts and the EdMon52 source code in my GitHub. I have provided the link in the description. For now, that's it, and I'll see you in the next video. Bye!